Hey guys, welcome back everybody. So let's get started with the multicasting. It's a very important topic. Okay, so let me remove my watches. So let me tell you one thing before I'm going to start the multicasting. Hi everybody. Hi. So by default, not by default, I can say that. If you remember that, we have three types of traffic, right? We have three types of traffic. One is called the unicast. In the unicast, what happens called the one-to-one communication, right? Then we have a multicast. It's called as a one-to-group communication. A very good example of the multicast you can call as a WhatsApp group. A WhatsApp group is a very good example, right? Just right now because you know the things, okay? But I'll give you the another example as well later. And then another types of traffic we have a call as a broadcast traffic, right? So you may have this term anycast, right? This is not any kind of traffic, right? Majorly the types of traffic we have a unicast, multicast, and broadcast. Anycast is not a kind of traffic. And in broadcast, what happened? We have a one-to-one, right? So we have basically three types of communication, right? Or we can say the three types of traffic we have in the networking: unicast, broadcast, and multicast. Now, if I'm going to give you the example of this one, try to understand in this way. We have a user one. Okay. Let me bring it down a little bit. Right? Then we have a user two. Then we have a user three. Right? And then we have a user four. And all these users are connected right now via the switch. So we have a switch in between, right? So I will connect this guy. Right? Switch what? PC2, PC3, and PC4. Understand right now. So IP address of this person is, it's called as a 10101. That's I'm going to define the IP address for this guy's 10101. And I will define this guy's MAC is A of there. This guy's IP address will be 10102. This is the MAC address is B. Guys, please pay attention. It's very important because if you don't understand this part, then there is no need to understand the complete multicast. Then we have a PC3 that has IP address will be 103. This is the MAC C over there. Then we have a PC4, right? That has IP address is 104 right now. And the MAC will be, oh, come on, MAC will be over there, right? So understand this is the interface. We have a 0/0. I'll make it 0/1. This guy's go with the 0/2 right now. This guy go with the 0/3, and this guy go with the 0/4. Okay. So normally what happens if the PC1 wants to communicate with the PC2? If the PC1 will communicate with the PC2, in that case, what happened? This communication is called a one-to-one communication. This communication is called a one-to-one communication. That's called a unicast communication. Take example, what happened if the PC1 wants to send the data to the everybody. For example, if this will send our data to the everybody, this guy, and this guy. That's kind of communication is known as a broadcast communication. That's called a one-to-all. But if I'm going to make a group of that one, I'll say, hey, instead of sending the message to the everybody, I'll make a group of this one. So this is the group of there. So in this group, we have a PC1, PC2, PC3. So now what happened? If the PC1 will generate any packet, right? If the PC1 will generate any packet, it will go to the PC2 and PC3. In that case, the PC4 will not listen the any kind of packet. That's called as a multicast, a one-to group. So I have just created the one logical group. And in that logical group, I have put the IP, I have put the users over there. Now, this is the very layman example that I give you, but in a reality, it's a little bit different. Okay, but this is the layman how you can differentiate the unicast, multicast, and broadcast. Now, the question is comes in again picture. If you already have a right, if you already have a unicast, if you already have a broadcast, then why multicast comes in the picture? Okay, before I'm going to explain you this part, you need to understand this part as well. In IPv4 addressing, right? In IPv4 addressing, we have a different classes. So we have class A, if you remember that. In a class A, we have a ranges 0 to 126, right? Then we have class B. that we have a range is 128 to the 191. Then we have class C, right? In class C, basically we have a range is what? 192 to the 223. And then after that, we have class D, right? And then class D, we have a 224 to the 239. And then finally, we have class E. The class E, we have a 240 to the 255. That's reserved for the documentation, docs, and future purpose. If I talk about the class D, man, the class D, that's totally reserved for the multicasting. The class C and E, it's reserved for the unicast and broadcast, because each subnet of the last IP is called as a broadcast ID. We have the class B as well, unicast and broadcast, and class A as well, unicast and broadcast. So the majorly till this point, whatever the things we have discussed, guys, we have discussed this guy only. Till this point, in the last 3 months, we have only discussed the class A, class B, and class C. Today, our main agenda is what? Our main agenda is to focus on the class D. So the class D is totally represent the multicasting. And this is the flat network, right? The meaning of flat network means what? We don't have any subnet mask information in the multicasting. You cannot do the any subnetting for this guy. Like you did the subnetting for the class A, class B, and class C, right? We have a subnet mask information, right? We can follow the hierarchy over there, but this is the flat network. We don't have any subnet mask information, right? And we cannot do the subnetting for this guy. Okay, in future, when you go to the CCI label, you find something that I have, take example, I have a 223 dot, not 223, 224.10101, and I will put the slash notation, maybe the 16 over there. What is the 16 now? It's a subnet mask, but the use case is different. You will understand in the later, right? So in types of traffic, then we have seen that the IP address in the class D is totally reserved for the what? This is totally reserved for the multicasting only, right? Now, how you can identify the traffic? It's simple, simple behavior. For example, if you have a unicast traffic, right? Then you have a source MAC will be unicast, destination MAC will be unicast, and the source IP will be unicast, and destination IP will be unicast. For example, we have a source MAC will be, for example, we have a A, that's a source MAC. Destination MAC will be B, source IP will be 101.1, and destination IP will be 101.2. This packet is called as a what? This packet is called as a unicast packet. Right? Then after that, what happened? Same basic example, we have another packet structure. We have a source MAC, destination MAC, source IP, and destination IP. So now what we can do that, I'll put the source MAC will be A now. Destination MAC will be FFF, that's a broadcast MAC address. I don't have a space, I'll put it over there. And destination source IP will be 101.1, and destination IP will be, let's put the broadcast IP of this subnet, right? Same information will be there. Right? So this packet is totally represent a broadcast packet. Right? Then after that, what do we have it? We have a multicast packet. In multicast, what happened? We have a source MAC, destination MAC, and the source IP and destination IP. Take example. This is the router number 1, and this is the router number 2. And we did enable the OSPF protocol over there. As we know that in our OSPF protocol, what happened? The hello packet will be exchanged on the 224.0.0.0.5, right? That's our 224, right? This is the range starting from the class D. It means that's a multicast address, right? So router 1 will send the hello packet on the multicast address .5 with the source IP will be what? Source IP will be 101. For example, this IP address is 101, this is IP 102. So source IP will be 101 and destination IP will be .5. So this is a multicast packet. So source MAC, I'll put this guy as a A. and destination MAC, what I can do that. So destination MAC, right? So destination multicast MAC is basically copied from the multicast IP address. How this thing is conversion is happening, how the layer 3 IP addresses help you to give the layer 2 multicast MAC address. How the layer 3 multicast IP address, how the layer 3 multicast IP address helps you to give the layer 2 multicast MAC address. There is a global rule for this one. Okay, it's a big topic. So no need to go on that one right now. Okay, how this thing is conversion, right? You will learn in this CCI part. Okay, but this is the huge topic. It's a 1 hour of the session only to understand there is a behavior of this one. So I'll just show you that. So basically your MAC addresses, the layer 2 multicast MAC addresses is inherited from the layer 3 multicast IP addresses. So I'll put the MAC address for this guys. What? So the first 25 bits, right? It's totally reserved 01005B. So whenever, anywhere, right? Anywhere, either you will see the EIGRP hello packet, either you will see the OSPF hello packet, either you will see the RIP packets, or either any multicast MAC address, you will see that always start with the 01005B. This bits, right, is reserved. So you may say that, hey, Lloyd, this is the only 24-bit. MAC address is a 48-bit. This is the only 24-bit. There is a long history behind it. So it's not a 23 bits. Almost 25 bits are reserved, right? And right now you can see the 24-bit only, but there's a 25 bits reserved. It's a big history type behind this guy. And the remaining bit, what happened? It will copy it from this guy, the layer 3 IP address. So I'll say the 0000 and 05. So this is the multicast MAC address for the OSPF protocol. If you just go on the router, let me show you this thing. So I'll come on. I have a multicast, unicast. Oh, that's fine. I can do this live, right? I just want to show you the hello packet. Meantime, I'll just write on the source IP information 101, and the system will be .5, right? This is the source MAC. Guys, please pay attention. I'm just giving you the overview right now. This overview is very important. Distance MAC, how you can differentiate, how the router will identify which one is a unicast packet, which one is a broadcast packet, and which one is a multicast packet, right? And then this is called a multicast packet. One thing on the Cisco CLI, what happened? When I say the ping 1 or 1 or 2, that's my destination IP address. By default, router will 5 packets. On Cisco CLI, when I say the ping or broadcast IP, by default, router will generate the 5 packets. When I say the on Cisco CLI, when I say the ping any multicast address, let's take example .5, right? This is the multicast address. Router will generate the only 1 packet. Now you have to connect this dots in the letter class. You have to connect it. This is a very important major difference. Only 1 packet, the Cisco CLI, not in a Cisco CLI, even if you go with any vendor, they will generate the only 1 packet. That's a beauty part. You will understand why. I'll come to the point, but let me show you this part right now. So let's focus on the router 1 and router 2. So let me take a console of the router 1. Console. Come on. It's a bit slow, man. I'll better do one thing. I'll make a one lab for you as well. So that I can show you the practical. 1 minute. Before I'm gonna explain the practical part, I'll give you the theory, don't worry about that. So better do the multicast. CCNA. So I have a router speed router 1, 2, 3, 4, 5. 5 is enough. So in the 5, what I can do that, I'll make this guy router 1. I'm just gonna change this guy as a symbol. I'll make this guy the router 1 as behave like my server. Right? Forget right now what I'm doing. Okay. I'll come to the point. This guy will explain you everything. And that's we have router 2, we have over there. This is my router 3, this is my router 4, and this is my router 5. That's my client. Okay, and I have another link between this guy. I don't have a port, the fast Ethernet cable, so I'll add it over there. Configure slots, and I'll add the two FETX as well. Same here, I can add it. And here we go. Okay, and right. So before I'm going to show you that multicasting practical, I just want to show you the OSPF behavior, the multicast MAC address. That's very important because I want to discuss this part first. Then I'll come to the practical part. So config terminal, I'll give the right now in the interface 0/0. 12.1/24. And on the router 2 as well. Router OSPF from what? Area 0. Area 0. And let's capture this link and have a look. That's most important about the MAC address. So we know that, right? The multicast IP address of the OSPF is a .5 for all OSPF router and .6 for the DR and VDR. If you see this is the .5 packet, so router 1, that's a 10.1.12.1 is sending the packet on the .5. If you see the multicast address is 01005, that's 24 bits. It's totally reserved one, right? Actually, it's a 25 bits. And this few bits are reserved from here as well. But just make a easy understanding. Just understand this at 24 bits. It's always 01005E. And the remaining bits are 0, right? 0. And then this 5 is go with this guy. So that's how the multicast MAC address is calculated. You know, there's a many things in the multicast MAC address as well. If you see that we have LG bit, that's a globally unique address, and the IG bit as well, that's a 1 over there. There is a use case of this thing, right? But again, I cannot explain everything in the one class, right? So leave for the CCA part. Now, the question is that now you have understood, right, how you can identify the unicast, broadcast, and multicast packet, and how you can see the types of traffic as well, and the IP addressing part in the class days for the multicast. So if you see any IP addresses that's belong to this guy, we have a multicast IP. Now, one more thing. Normally, what happened on the interface or maybe the PC, you assign the IP address 1.1.1.1, right? This multicast address you cannot assign to the any interface. You cannot assign to the any router interface. You cannot say the router 1 and this interface 0/0 as the IP address would be 24.1.1. You cannot do that. The reason is that because here what happened in the unicasting, in a unicast what happened, the class A, class B, what happened, one IP address represent one PC. Another IP address will represent another PC. Another IP address will represent another PC. Another IP address will represent another PC, right? But this is the unicast behavior, class A, class B, class C. But in the multicasting, what happened? A multicast means what? A multicast represent a group. Multicast represent a group. So basically, you are defining the group IP. So I'll make a this guy as a group. I'll say for this guy the IP will be 226.1.1.1. And that's my favorite. That's my favorite IP of multicasting. I always use this IP addresses in my all practical. So I can assign this is my logical group that I have defined. And for this logical group, I have defined the IP address will be 226.1.1. Let me give you a very good example to you. You have joined the Zoom right now. What do you call? Is this Zoom is a unicast or broadcast? What do you think? It's a multicast. How? The reason is that I gave you the link and you have joined that particular link. You have joined that particular link. So when you click on the link, then you will come to my lobby, right? Same thing. When you watch the YouTube, is that a multicast and broadcast? It's a multicasting. It's not a broadcasting. The reason it's a multicasting because when you're gonna turn your laptop, when you go on the Google Chrome and just put the YouTube, then you will watch the video. So you are requesting to the server, I need a videos over there. So the reason to introduce the multicasting is what? For example, take example, we have a server over there, right? And understand this is the Netflix server, right? This is the Netflix server, and this server has a, I'm assuming that this is the multicast address for this guy. This is the router we have, and this is router we have, router 3 as well, router 4 as well, router 5 as well, and router 6 as well. And this guy is connected. So take example, we have a user over there, right? So the first of all, why I can't use the unicast? I can assign the IP address for this guy to 101.1, and the user that are sitting over there 2.2.2.1 and the 3.3.1.1.1 and the 4.4.1.1, they can get the they can watch the Netflix movie through this server, right? They can watch it. But if take example, if I'm going to assign the 101.1, right, unicast IP address, if I'm going to use the unicast mechanism in this topology, then what happened? Understand the concept. If I'm going to use the unicast mechanism in this topology, then what happened? If this user wants to see the any movie, they will request to the server, hey, I need a stream for the some movies. Then the server will give the stream to this PC, right? So take example, this bandwidth of the bandwidth of this particular link is of 4 Mbps. And this bandwidth of 4 Mbps, 4 Mbps, 4 Mbps, 4 Mbps only, right? What happened? If I'm going to use the unicast mechanism, then what happened? If this guy will request a multicast, not multicast, if this guy is request for the movie, then they will consume the 2 Mbps bandwidth. A roughly example. If this guy will interested to watch the movie, then they will request to the server, hey, I also need a stream. I also need a data. So they will also request for the 2 Mbps. Now what happened? This link will be exhausted. Now, do you have any bandwidth? Because this PC allocate the 2 Mbps, this PC allocate the 2 Mbps. Now, do you have any bandwidth for this guy now? There's no bandwidth, right? That's why unicast mechanism is not a successful. Unicast mechanism is not a successful because in a unicasting, what happened? It's a totally wastage of bandwidth. Then that's why then what happens? A broadcast comes in the picture. So but the problem with the broadcast is what? Take example, if the server will generate a broadcast packet, source will be 101.1, destination will be 255.255. Take example, right? Then what happened in that case? The broadcast packet will comes to the router 1. Router will forward the broadcast packet? No, never. By default, broadcast is disabled, right? If you just go on the interface, do show IP interface 0/0. If you see that by default broadcast is disabled. So maybe you have a question, hey, Law, that's fine, I can enable it. It's a by default, it's a disabled, right? We can enable it. That's not a big deal. I just need to go on the router side, interface 0/0. I said the IP directed broadcast. It's done. Now router will start forwarding the broadcast packet. Take example. If the router will start forwarding the broadcast packet, then what happened? If only this user has requested for the stream, they will receive the broadcast packet. They will also receive the broadcast packet. They will also receive the broadcast packet. They will also receive it. They will also receive it. They will also receive it. Did this user has requested for the did this user has requested for the traffic, the Netflix? No. Did this user has requested? No. Only this user has requested for the stream. But what happened? They can watch the movie right now, but the problem is that still this whole the network will be receive the traffic. That's a biggest issue with the broadcasting. First of all, it's not a good way to enabling the broadcasting on the all the router. By default, this feature is disabled on every vendor. So you cannot enable the broadcasting. Okay, so take example, this Netflix is in India right now, and they will give you the Hindi movies. And this router 3 is connected to the China router, right? And the Chinese people can understand this Hindi language. They cannot understand the Hindi language. So that's why the broadcasting is not a feasible solution, right? And that's why we came with the solution called the multicasting. In a multicasting, what happened? In a multicasting, if this user has requested for the traffic, then what happened? Already take example. In multicasting, what happened? If this user has requested for the traffic, they will request for the server, hey, I need a multicast stream. I need I need to watch some movie. Then he will give the stream to this guy, right? So already the stream is coming on the router 4 interface, right? Already the stream is coming to the router 4 interface, right? Then what happened? It will consume the 2 Mbps, take example roughly. Now, if there are this PC will request for the multicast stream, then what happened? He will inform to the server, hey, I need a multicast stream. R4 was already receiving the multicast. He will just pass the multicast stream to the R5. In that case, I'm still gonna use the same bandwidth. If this PC will request for the multicast stream, then what happened? He will just request for the router, hey, I need a multicast stream. Router 5 was already receiving the multicast stream. They will just pass on the multicast stream to this PC. So still my 2 Mbps link is available right now. So I can save the lots of bandwidth. I just give you the explanation right over here. If you see that, this part. only one packet. Whereas if you go in this two guys, they will generate the 5 different packets over there. So in a broad multicasting, what happened? The first benefit is that we are resolving the issue of the unicasting and broadcasting. Now, where the multicast comes in the picture. So watching the movies on the Netflix, Amazon Prime, Hotstar, live matches that you're watching, radio channels, right? YouTube videos, Zoom link, WhatsApp call, WhatsApp video call, audio call, right? Whatever that you are seeing nowadays, every single thing is multicasting. Because you are joining that particular group. So maybe you have a question, hey, Lord, I don't see that Netflix is the multicasting. Dude, the meaning is that the multicasting is what? Whenever you are requesting, whenever you are opening your laptop and maybe the television, you just click on the Netflix and then you are watching the movie. Then it means that you're requesting to the server, I need a stream. By default, broadcasting means what? Continuously sending. Did the Netflix is sending the continuously packet to you? No. When you request it for the Netflix server, I need a stream. Then stream is what? Data. Just understand, when I'm using the stream term, stream is what? I'm talking about the data. So when I requested for the stream to the Netflix server, then he will give the stream to me. That's a concept in the multicasting, not the broadcasting. Everything that you're seeing nowadays, right? Watching the match online, multicasting. You just join the Zoom link right now, it's a multicasting. So in a multicasting, what happened? We have a separate IP concept. Like as I mentioned that you cannot assign the multicast IP address to any router or any PC. Multicast IP address just gonna represent a group, right? So for example, I'll make this guy the 2 group right now. For this 2 group, I'll put the 226.101.1, and for this 2 group, I'll put the 226.101.2. Can you see that? For this 2 PC, I just have a 1 multicast address. For this 2 PC, I just have a 1 multicast address. So if I'm going to say the ping, understand the concept. If I'm going to say the ping 226.101.102, who will give the reply? PC3 will give the reply and PC4 will give the reply, because I'm pinging to the 226.101.102. So in this group, only these 2 users are sitting. If I'm going to ping the 226.101.1, the PC1 and PC2 will give the reply. Because in this 226.101.1, only these PCs are present. Okay. So this multicasting has a own world, like you have learned the unicasting and the broadcasting concept, like you have a EIGRP, you have a LAN communication, right? You have a LAN protocols. Same thing in multicasting, we have a separate thing. So like in a multicasting, first of all, what you have done in a multicasting, we have a separate thing is a class D, a complete separate IP address format. In a multicasting, we have a separate WAN communication. We can call it the layer 3 communication. That's called as a PIM protocol. So here we don't have like a EIGRP. We don't have those things. We have initially it was a DBMRP protocol and MOSP protocol. Initially it was there, right? But this 2 protocol is totally obsolete now. So we are not using it. There's a problem with this protocol. We'll discuss this thing later. Okay. So, but we are not using it, so obsolete. So right now the corporate is using the PIM protocol for the L3 communication. L3 communication is what? Router to router communication. We are using the PIM protocol. But in the LAN, we have a layer 2, we have a IGMP protocol. IGMP is not a layer 2 protocol. I'm just saying a layer 2 network. IGMP is a layer 3 protocol. So take example, if the router we have, and then we have a switch over there, and then we have a PCs over there that's connected to the switch over there. And if this PC wants to provide the communication between this router to the PC, right? We need to run the IGMP over there. So we have 2 things like similar to the unicasting. We have a class A, class B, class C, separate multicast address. In a multicast, we have a separate multicast address. Separate addressing mechanism we have. Like we have a EIGRP OSPF, BGP. We have a separate protocol like a PIM. in the layer 3. Like in the layer 2, we have a 80.1 queue and those things. We the VLAN protocols. Same thing in the LAN, we have IGMP protocol over here. So in a corporate right now in the world, complete world, your multicasting is totally depend on the two things, PIM and IGMP. That's all. And it's a huge. Now, so the first of all, your router must support the multicasting. Then you can do the multicasting on the router. It doesn't mean that every router support the multicasting. Some of the routers support the multicasting. Some of the routers doesn't support the multicasting. Right? So take example, if you see this topology right now, right? I have, let me do one thing. I'll make this guy as a user over this guy. I'll change this guy as a symbol. I'll make this guy as a by default multicast feature is disabled on the router side. So understand this is the my client we have, right? And this is the one of the Netflix server. Right? And this is the client that wants to watch the some movie over there. So normally what happened between here to here, router to router, we are gonna run the PIM protocol. Router to router, we are gonna run the PIM protocol. Router to router, we have run the PIM protocol. And here to here, we are gonna run the IGMP protocol. Here also on this particular interface, we are gonna run the PIM protocol. So that's how your communication is gonna happen. So this is multicasting. So under the PIM, we have a flavors, multiple things we have under the PIM. Under the IGMP, we have a multiple flavors as well, right? So that's not important. So let me give the IP part. So I'll give the 12.1. This guy will be the 10.1.12.0, 12.2, 23.2. This is the 23.3. Here we have a 10.1.23.0/24. Here we have a 10.1.24.0/24, 24.0/24. Here this guy's a 34.3. Here this guy's a 34.4. Here this guy's a 10.1.34.0/24. And here we have a 10.1.45.0/24. So of course this guy will be go with the IP address. Sorry, I'm forgot to mention that 45.4, and this guy will be 45.5. So let me do this configuration in the notepad. So in the router 1, the first task is what? Task 1, configured IP address. R1 we have interface 0/0. It's 10.1.12.1/24. No shit, guys. Your agenda is what? You need to understand the concept, like how the unicast is different from the multicast. Okay, your agenda is not to learn the practical part right now, because nobody will ask you what is multicast in the interview. Nobody. Even if you are a CCI candidate, very rarely you will encounter the multicast question. Rarely. Personally, I'll tell you, I have encountered only one time that the multicasting question in an interview. I give the multiple interviews, I just encounter one time only. Very rarely. The reason I'll tell you, because even in the production network, what happened, people are people don't know about the multicast, and people are afraid from the multicast as well, because it's little tricky things. Because to do the multicasting, your unicast must be clear. If you don't have a good knowledge of the unicast, you cannot do the multicasting. So that's why people are afraid from the multicast, and that's why they don't ask the multicast. They will just ask, okay, can you explain me what is the difference between the multicast and unicast? And then, like, if they will have an idea a little bit about the multicast, then they will ask, okay, what is PIM protocol? And what is the IGMP protocol? And what's the difference between that? That's all. But again, at the eye level even, I haven't seen that. So no need to worry that. No need to focus on the config part. You need to only understand the difference. If you understand this part, then you will be able to explain yourself to how, why the multicast comes in the picture. And I'll say that on there are two as well. Configuration by multicast is pretty easy, man. Pretty easy. If you know the unicast, the configuration is pretty easy. But if you have an issue with the unicast like OSPF and EIGRP, then it will become hard for you, man. And I'll tell you one thing. You will encounter this multicast everywhere. Either you are learning the CCI enterprise, either you are learning the CCI service provider, either you are learning the CCI data center as well. Even the CCD too, man. CCD has a lots of questions for the multicasting as well. So you will encounter this thing in many ways. MPLS, multicasting, quality of service, BGP, OSPF, these are the, you will find everywhere. So if your enterprise part is good, right? If you have a good knowledge in the enterprise at the NP level or the I level, anything, if you have a very good knowledge, then you can do any track. Doesn't matter. But for example, people are used to, like, I have seen that many people are used to say, hey, law, I have seen, like, security has a very good market. Man, if you do the security, then you can only do the security. You don't have any alternative option. Because in the security, you're not going to learn about how the OSPF is working, how the EIGRP is working, and how the multicast and the QS is there. You are only going to learn about the security tools. That's all. That's why I always say to people, hey, first complete your enterprise part, get the good knowledge of the routing part, so routing switching, and then go with the security if you have a plan. And if you are planning for the longer period of time, like like for me, I'm used to of networking, right? So my plans of the security is what I'm gonna learn the security at the end, like once I'm done with everything. So that's my plan. So maybe after the end of this starting year, I'm start learning the security part. See, it doesn't mean I don't have knowledge. I do have I read the firewalls, I read the ICE, I read the TT and those things even long time back. But I just have a knowledge of that path thing. Okay, I cannot teach anybody. So my always agenda is what focus clear the concept, because if your concept is clear, then you can learn any technology. R3, R4, R5 we have. R5 is my client, so better to do one thing else than no IP routing. I said IP default gateway. I just configure the normal IP addressing right now. Okay, so let's copy and paste it. Router 1. I'll say the no IP directory broadcast. I did enable it. Let me just save it. R2 we have. R3 we have. And R5. That's the final client. All done, man. So let's configure the routing protocol. So you can go with any routing protocol. I'll go with the OSPF. Configure step number 2. And I think so I missed the one video to upload it. So just remind me which video I missed that. I'll upload it. Okay. Config terminal R1 we have. So R1 is my server. I don't need to enable the anything on the server side, but just for the right now because it's basic classes, I'll just do that, enabling it, no issue. R2 we have. You can also go with the EIGRP man. I'll say there is also 255. Simple one. By putting the single command line, I did enable all the 3 interfaces. Same on R4. That's all right. That's a basic CCNA level stuff, right? I just match the 16-bit 10.1 and the wildcard 0.0 16-bit, and that's added as the route. Instead of putting 3 statement, I just put the 1 statement. On a route of 5, I already have a default gateway. So let's wait for the neighborship comes up. Meantime, I'll configure this guy's what? Step number 3, configure IP multicast routing on every router. Because by default, multicast feature is disabled. If you put the command, do show IP route, this command will show you the unicast routing table. But if you put the command do show IP mroute, that will show you the multicast routing table, miss multicast. It will show you the multicast routing table. But if you see that, it will say that multicast is forwarding is disabled right now. So it means that router cannot forward the multicast packet. If the router will receive the multicast packet, they cannot forward it. So you may have a question, hey law, multicast forwarding is not enabled, but still OSPF is there. And we can see that OSPF is forming the neighborship. How is possible? There is a reason. There is a reason behind it. Not explain you, but yeah, there is a reason behind it. So on the router 4, I got the neighborship. On the router 5, now we are multicast need to be enabled on every router. So on the router 2, also the IP multicast routing. On the router 3, also the IP multicast routing. This is the command to enable the multicast routing behavior. So after putting this command, what happened? Our router will start forwarding the multicast packet. No need to enable on the client side. It's a global configuration command. So you can just put in a global config mode as well. So now you can see that do show IP mroute. It will show you, hey, multicast is enabled. There's no error now. Next part is what? We need to enable the PIM protocol. Enable PIM. A PIM is standard for protocol independent multicast. Okay, there is there's a lots of the reason behind why the name is PIM. Okay, so route 2 we have on route 2 we need to enable the interface 0/0 IP PIM dense mode. So PIM has basically 2 mode, right? Either you can do with the dense mode or either you can do with the sparse mode. So right now I'm just using a dense mode. So on the every interface, we need to enable the PIM. So we have 3 interfaces, 1/0 as well and 4/0 as well. Do I need to enable on the server side? No need to enable. Server is a server, right? On R2. Once the PIM will be enabled on the R2, it will start sending the hello packet. So I need to enable on the router 3 as well, on router 4 as well. So once I'm going to enable on the router 3, they will form the, so router 2 and router 3 will extend the hello packet and they will form the PIM navigation. And router 4 as well. Sorry. Interface F4/0. R4 will also form the navigation with the R3 and R2, the PIM navigation. The PIM is up. We have enabled. Now a good thing. So we have done with the PIM now. So the good part of the multicasting is what? So we did the enable the PIM on this particular interface, 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 and this particular interface, right? We did enable it. Now we need to enable the IGMP over here, right? How do I enable the IGMP? So there is no separate command to enable the IGMP protocol. So once you enable the PIM on this particular interface, F41, so I'll say that enable IGMP now, step now 4. I think so step 5 is there. Step. Enable, how we can enable the IGMP? Of course, we need to enable the IGMP on the router for this interface, because IGMP should be there between the PC to the router, the gateway router. And if you have in between switches, then you need to enable the IGMP over there. So either you can enable the IGMP snooping, or you can go with the CGMP snooping as well. These two things you can enable on the switch side. So how you can enable the IGMP? The simple command IP PIM mode. So if you enable the PIM, automatically the IGMP will be enabled. So there is no command to enable IGMP. If you enable the PIM, the IGMP will be enabled. So if I'm going to say the router 4, this one command. So if you see, do show IP IGMP interface, IGMP has enabled. I just put the command, runs mode, F4/1, the IGMP is enabled. Right, version 2 is there. So we have a 3 version, version 1, version 2, version 3. Version 2 is by default 1. Version 1, we are not using it just for the, there's a lots of problem in the version 1. Big topic. And version 3 is, it's a recommendation one to use the version 3 just for the security, just for the security reason to prevent the attacks. So now we did. So what we have to do that on the client side, right? So normally how you join the Zoom right now. So in your laptop, maybe take example, if you have joined this classes. So in what happened, you did open the laptop, and what you did, you just log into the Zoom and you just click on my link, and through the Zoom you have joined my classes, right? Same thing in the phone. What happened? You have a Zoom app. You just need to put the link over there and you can join the classes, right? So you have a multicast application in your laptop, or we can say that in your phone, right? Same thing on the router 5. And then in reality, there is a multicast application over there. And in that multicast application, like a Zoom, like same way that there's a multicast application over there. In that multicast application, what happened? That you need to put the IP address of the multicast 226.1.1, whatever the IP address is. So I'm assuming that, 226.1.1.1, that's my server IP addresses. I'm assuming that. So you need to open the application, you need to put the IP address of the server. So, but right now, this is the route over there. How you can join this router as a multicast group? You just need to go into the interface, IP IGMP join group will be 226.1. That's all. So on the router 5, what I did, on the client side, we can call it. And now I go to the PC1. Ping 226.1. Oh, what happened? There's some mistake. Ping. To achieve the multicasting, your unicast must be reachable. If your unicast is not reachable, you cannot send the traffic. So let me see why it's not pinging. So IP interface brief. So IP read my default interface there. Ping 10.1.12.1. So I'm pinging from the PC5 to the server IP 10.1.12.1. If your unicast is not working, then your multicast also not gonna work. So my unicast is working fine. So I am not getting the multicasting now. Someone has put the question. Please, why did you use the dense mode for the R3 and R4? Because you have to enable the PIM over there. So PIM has a two flavor. Either you can go with the dense mode or sparse mode. So let me troubleshoot what's the issue right now, man. PIM neighbor. R3 has a two neighbor, R2 and R4. Perfect. PIM neighbor. R4 has a two neighbors. One is the R3 and R2. How about the R5? So run interface 0/0. I have joined the IGMP join with 226.101 and then come on, man. What's the problem? Oh, what is happening? Because the topology that updated, it's a low topology right now. So let me check if there is 46.1. Set. Got it. Still not. This is how I join the multi-control. Let's take example. Let me do one thing with the $1 over there. I'm assuming that's the one of the client. With the correct sparse mode, F/0, F/1. And then we have a sparse dense. Man, how I enable the sparse mode? Sorry, my bad. Dense. Okay, let me change this guy. My bad. Also like this. 0 चलो जी Yeah, getting the reply now. So getting the reply from both the users now. So there was a problem. I have my badly configured here I configure the dense mode, I configure the sparse mode. So that's our main issue is that getting the reply from both. So if you see that I'm sending the one packet, beauty part. I'm sending the one packet, getting the reply from both the users. So this is also one of my users. So both the users has joined the 226.101 Netflix server, and both the PC is getting the stream. So there's a one PC behind the router 3, and there's another PC behind the router 4. So you can see that one packet, only 100 byte, getting the reply from both the users. So if I'm gonna add the multiple users behind the router 4, if take example router 3, still I need to send only one packet. That's a beauty part of the multicasting. So I hope the myth is clear to everybody. So take example, if I want to send the broadcast packet, will I get the reply from the R6 and R5? No, you will not get that because broadcast is by default disabled. And if I want to send the unicast packet, then what happened? I need to separately send the unicast packet for this guy and this guy. Wastage of bandwidth. Two packet, right? One packet for this person and one packet for this person in the unicasting. Wastage of bandwidth. But in the multicasting, what happened? I just sending one packet and we replicate the packet to everybody. So within the LAN, we need to run the IGMP, or over the WAN, we need to go with the PIM. So there is only one protocol PIM. Flavors we have, PIM dense and sparse mode we have. Now, which flavor we are using in the market? We are using both the flavors, but mostly you will see the sparse. Mostly. 90% network, not the dense. So now you have a question, hey, Law, why you haven't shown the sparse mode configuration? The sparse mode is a little tricky for you. You will not understand. That's why. Anyone has a question in the multicasting, guys? Okay, apart from this thing, we have lots of things in the multicasting, huge thing. Like you can do the multicasting over the MPLS. You can do the multicasting over the GRE as well, or the DMVPN as well. You can secure the traffic of the multicasting with the help of IPsec as well. For example, your service provider does not support the multicasting, and your client, take example, this is the service provider, right? That does not support the multicasting. And there's the one server that's location in the Mumbai and client is located in the USA. Will they get the multicast stream? This PC will get the multicast stream from this server? Definitely they will get it. Doesn't matter your service part is enabled or not, the multicasting. You just need to create a VPN between this guy. And through the VPN, what happened? I can transmit my multicast data through the VPN. So bunch of things are there in the multicasting, right? Like about the PIM protocol and the IGMP protocol. So only about the IGMP, if I talk about, we have almost 12 hours of the session only on the IGMP, and then PIM almost we have a 10 hours of the session on the PIM only, 10, 15 hours session on the PIM only, PIM protocol. So almost 30 hours of the session on the multicasting we have. But I hope you enjoy the session of the multicast. Like you have a now get a better picture of the multicasting. Like what's the difference between the unicast, multicast, and broadcast, right? Why the multicast comes in the picture? Why we can't use the broadcast everywhere? Why we can't use the unicast in the Netflix or watching the match online or YouTube as well? Any cast is not any types of communication. It's just a one addressing mechanism we can call it. Anyone has a question, guys? Looks like nobody has any questions. Multicast, unicast. What is this? Is there any IP broadcasting? What do you mean IP? No, there is no IP any broadcasting over there. So you are asking there any broadcasting mechanism? Personally, I haven't seen that. Maybe it could be there. I haven't seen that. We cannot say anything no in the networking. It might be there, but I haven't encountered it yet. IP gateway. What is the IP gateway? I don't know what you're talking. One thing